Hello friends, we will start our discussion on the subject fluid mechanics. Now first of all, we will start our subject fluid mechanics with the introduction of fluid mechanics. The first chapter will be our introduction of fluid mechanics. What is the meaning of your fluid? What is a fluid and how a fluid is different from your solid and gases? How the fluid is different from solid and gas? What is the meaning of your fluid? Now in introduction of fluid mechanics, if we will study about starting is your basic concepts. Now if we will study what is a matter. Now what is the meaning of fluid, and if we will study first of all what is a matter. As we know, a matter is a substance, or a matter is anything. If I would write here, a matter is anything, a matter is anything that has mass, that has some mass, and it will occupy some space. A matter is something which has some mass and it will occupy some space. We will say that any substance which will occupy some space and has some mass is known as your matter. And if we classify the matter, we will know that the matter is of three types. If we will say the matter's classification, the matter will be of three types. The first one is your solid. The matter would be classified in three types. The first one will be our solid. Matter's classification. The first type of matter is your solid. The second one will be our liquid. The second one will be our liquid, and the third one will be our gas. The matter will be classified in three types. One is your solid, one is your liquid, and the last one is your gases. And the liquid and your gases combinedly known as, these liquids and your gases will be combinedly known as your fluid. Means if we say a fluid may consist of a liquid and it may consist of a gas. The liquid and gas is considered as a fluid. So the matter will be classified in terms of your solid, liquid and gas, or you can say that matter will be classified in terms of your solid and fluid. Now if we will say what is the physical significance of your solid and what is the physical significance of your liquid and gases. If we will study about first of all the physical significance. The physical significance. What is the physical significance of your different types of matter? We will start with our solid. First of all, we will start the discussion with your solid. As we know, what is the solid? A solid is a substance. If I would say a solid is a state, or solid is that matter in which the molecules of a substance are tightly bound to each other and the molecules have a fixed position in a space. Means solid is that substance. If I would write the definition of solid here, I would say a solid is a substance, or a solid is a state of matter. A solid is a state of matter in which the molecules of substance, in which your molecules of substance molecules of substance are tightly bound. This is the most important thing. In solids, the molecules of a substance are tightly bound to each other, tightly bound to each other, tightly bound to each other means they are very closely packed. The molecules are very closely packed, or we can say that the molecules of a substance are tightly bound to each other as the molecules have, and we will say these are tightly bound to each other as the molecules have, as the molecules have a fixed position in space. A fixed position in space means the molecules of a solid substance or a solid state will not move. They will require a fixed position in a space, a fixed position in a space, and if they are fixed, the molecules are fixed and tightly bound up to each other, the solid substance exhibits, we will say, then the solid substance exhibits your rigidity, and exhibits rigidity means the solids are rigid. Rigid means, what is the meaning of rigid? Rigid means the distance between two molecules of a solid or two molecules of a substance will not change if we apply some forces on it. What is the meaning of rigid? The rigid body is that body, or we can say if a solid is a rigid means the distance between two molecules of that substance. The distance between two molecules of that substance will not change if we apply some external force in it. Matlab, if we apply some force, say we apply some forces of 10 kilonewton or 20 kilonewton, if the body is a rigid body or if the body is a solid, the distance between two molecules will not change. Then we can say that it will behave as a solid, and it will exhibit rigidity, and it will have some distinct shape, and it will have some distinct shape. A solid body or a solid state must have some distinct shape. Means solid have their own shape because of the tightly bound molecules. Because of the tightly bound molecules, and if we will say that the molecules are your tightly bound, if we will say the molecules are tightly bound, it means the intermolecular distance between the molecules are very less. Means if I would write, because of this tightly bound nature, the intermolecular distance means the distance between two molecules of solid. The intermolecular distance in a solid are least. In a solid are least means the intermolecular distance, or the molecules are closely packed. The molecules are very closely packed in solid, and if the molecules are very closely packed or very near to each other, we will say that the intermolecular forces of attraction are strongest in case of solid. Means if the intermolecular distance, if this is least in case of solid, then we will say that because of this intermolecular distance, the forces of, or we can say the intermolecular forces of attraction, intermolecular forces of attraction are strongest. Means in solids the intermolecular forces of attraction, or you can say that the cohesive forces of attraction are strongest in case of solid. So this is the physical significance of solid. Solid is that state in which molecules of a substance are tightly bound to each other and they will have some fixed position in the space. They will have some fixed position in a space, and if it will have some fixed position, it will exhibit some rigidity, and if it has a fixed position, that means the solid must have a distinct shape, and the intermolecular distance in a solid are least, means they are closely packed, and if the intermolecular distances are very least, then the cohesive forces of attraction or the intermolecular forces of attraction are strongest in case of solid. Now if we will talk about your liquid, the second state of ours is your liquid state. If we will talk about the second one, is the second classification of your matter is your liquid. What is the physical significance of liquid? How we can correlate this liquid with respect to your solid, and how we will classify or how we will physically signify the liquid. In liquid, we will say that the intermolecular distance between the molecules of a liquid are more as compared to the solid. Means if I would write here, the intermolecular distances between the molecules of liquid are more as compared to solid. Means as compared to solid, the molecules of liquid state are more apart, more far. Means if we will say here that if we will show a relative diagram of this, then if I would say these are the molecules of your solids, this is the distance, there is a very least distance between the molecules of solid, then the distance between the liquid particles or the intermolecular distance between the particles are more as compared to solid. This will be, we will represent it as a solid. The distance between these two molecules are known as your, this distance is known as your intermolecular distance. And in case of liquid, we will say, in case of liquid, the intermolecular distance or the distance between two molecules are more as compared to solid. And we will say that if the intermolecular distance between the molecules are more as compared to solid, we will relate liquid with comparison to solid. We will not relate liquid as an absolute term. We will say the intermolecular distance between the liquids is more as compared to solid, which implies that the intermolecular forces of attraction, this is a this is a very inverse relation. If the distance is more, then intermolecular forces of attraction will be less. If the two molecules are far, then the forces of attraction between these two molecules will be less as compared to solid. So we will write here, because of the more intermolecular distance, the intermolecular forces of attraction, in case of your liquid is less as compared to solid. We will define the liquid parameters with comparison to solid as compared to your solid. As compared to solid. And also we will say in liquids, the liquid state or the liquid matter has no definite shape. A liquid is a substance. A liquid is a substance that does not have a definite shape. It does not have a definite shape. As we will say in solids, the solids have a definite shape. We will write here that a solid must have a fixed position, or we can say it must have some distinct shape, but liquid is that substance which will not have a defined shape or a definite shape, and liquid will acquire the shape of that container in which we will fill that liquid. Means if we will fill water in a bottle, that water will acquire the shape of that bottle. So the liquid state will not have the shape of their own. It will acquire the shape of the container in which we will fill the liquid. So this is the physical significance of your liquid. Now if we will say what is the physical significance of your third matter, that is your gas. What is the physical significance of gas? The third one is our gas. The third one we will study about is your gas. So if we will say what is the physical significance of gas, if I would write that in gas, the intermolecular distance between the molecules of a gas are maximum. The molecules of gases are separated by a very large distance, or we can say that the intermolecular distance between the two molecules of a gas are very, very high. And if the intermolecular distance between the gaseous particles or your gaseous molecules are high, then the cohesive forces of attraction or the intermolecular forces of attraction will be least in case of your gas. And in your gaseous state, we will say that the molecules are in state of random motion. I would say in gases, the molecules are in your random motion. Means the molecules of gas are moving randomly in a space, but in case of solid and in case of liquid, the molecules will not move randomly in your space, but the gaseous molecules will be move in a random motion, and the intermolecular distance we will write here, the intermolecular distance in gases are more as compared to both liquid and solids. As compared to both solids and liquids. As compared to both solids and liquids. The intermolecular distance in gases are more as compared to your solids and liquids, and if intermolecular distance is more, then the intermolecular forces of attraction, these are the inverse relationship, then the intermolecular forces of attraction are very less are very less as compared to solid and liquid, as compared to solids and liquids. Means, if we will say in solids the intermolecular forces of attraction are strongest, and the distance between the molecules are very less. In case of gases, the distance between the molecules are more, and the forces of attraction between the molecules have a very least, and because of these least intermolecular forces of attraction, it will not have a definite shape. We will say gases will not have a definite shape, as in case of liquids the gases will not have a definite shape. It will not have a definite shape, and like that of liquid, the gases will acquire the shape of your container in which we will fill the gas, as in case of liquid, but solid will have a definite shape in the space. So these are the various physical significances of your matter, that is your liquid, solids and your gases. So if we will discuss about your fluid, now we will take the discussion on what is your fluid. What is the meaning of a fluid? How we will define a fluid with comparison to your solid. What is the meaning of a fluid with comparison to your solid? We will say here, if I would write the definition of a fluid, we will say a fluid is a substance. A fluid is a substance. We will say that a fluid is a substance which is capable of flowing, which is capable of flowing, which is capable of flowing under the action of shear force. I am explaining this. First of all, I am writing the definition. A fluid is a substance which is capable of flowing under the action of a shear force. Under the action of a shear force, and we will say that however the small shear force may be. However, the small shear force may be. This is the very important definition, very important thing, that however we will apply a very small shear force on a fluid. Please note here that this is a concept of your fluid mechanics, that if we apply a very small shear force, on a fluid, because of that shear force it must flow. It must flow because of that shear force. Now what is the meaning of this? Now if we will compare, as we will study the shear forces of solid, the shear forces in solid in your strength of material. Now if we will say what is the difference between, if I have to define this statement, this fluid definition, I will write to compare solid and fluid. Now if we say what is the difference between your solid and liquid or solid and fluid, the difference between your solid and fluid. This is the definition of fluid, that if in a fluid or if in a liquid or gases, if I apply some shear force, please note that I am saying here not force, the force must be a shear force or your tangential force. If I apply some shear force, a very small shear force maybe, a very small shear force if I apply on a fluid, it must flow. It must flow, which means that if I would talk about your solid and liquid, first of all, I would take the example of a solid. Please note here that suppose I have a solid body here. This is some fixed space, fixed particle or surface. In this, I would place a solid body. This is the solid body of us. We will put a solid body here. This is a solid body. And this side of solid body is fixed. This bottom side of solid body is fixed. Now on this solid body, if I apply some shear force on this solid body, if I apply, suppose if I apply some shear force F on this solid body. So because of that shear force, we will study in your strength of material that because of this shear force, the shear strain will occur in your solid and this body will deform like that. If I would like to name the sides, that is, if I say the sides are, suppose this is your point number A, this is your B, this is C and this is your D. If I am naming the surfaces of your solid and if I apply a shear force on this solid, then this body will deform and it will acquire the shape like that. The side AB will become, this body will deform in this manner. The side AB will become this and the side CD because of this shear force will be deformed like that. Will be deformed like that. We will say this point will be your B dash, this point will be your C dash, and because of the shear force F which is acting on a solid body, the body will be tilted when acquire the final shape, that is your A, B dash, C dash, D. A, B dash, C dash, D will be the final shape, and we will know from our strength of material that this angle which we will define with the help of gamma, this angle is known as your shear angle, or this gamma is known as your shear strain. This gamma is known as your shear strain, or the shear angle is gamma. In case of solid, this angular deformation or this gamma is constant for a constant force. Please understand here, in case of solid, if I suppose that if I apply a 10 kilonewton force on this solid body, suppose if I apply a 10 kilonewton shear force on this body, then this solid body will be sheared, will be displaced or deformed with this angle gamma, which we will known as your shear angle. This gamma is constant for this 10 kilonewton. Means if I apply this 10 kilonewton, we will say that this gamma would be suppose 1 degree. Means that because of 10 kilonewton force exerted on this body, 10 kilonewton shear force, it will acquire a constant deformation or a constant strain. Means in case of solids, this strain gamma will be a unique value for a unique force. Means whenever you apply this 10 kilonewton force on this body, then it will always displaced, or it will always deformed by a 1 degree. This 1 degree is constant for 10 kilonewton, and if we will increase this force, then we will get this gamma value to be changed. Hence, in your solid, your deformation is constant for a constant force. The deformation is constant for a constant force, and also if this constant force F, which is of 10 kilonewton, if this constant force is within the elastic limit of this body, if this 10 kilonewton force is within the elastic limit of the body, then if we remove that force F, which is in the elastic region of that body, the body will regain its original shape. This is the concept of your strength of material. We already know that if you remove that force till this force F 10 kilonewton, suppose I will apply this 10 kilonewton force on this body for 5 minutes. For that 5 minutes, the deformation is constant in this body, which is equal to 1 degree, and after 5 minutes, if I will remove this force, then if this force is in your elastic limit, then the body will regain its original shape. Then the body, which is deformed to your A, B dash, C dash, D, after the removal of this force F, it will regain its original shape and it will come back to the position A, B, C and D. This is the meaning of your solid. In solid, the body will regain its original shape, and in solids, the deformation is constant for a constant force. But if we will talk about your fluid, if we will talk here about what is the physical significance, of fluid, suppose I would say that there is a surface, there is a plate here, there is some surface here which is a fixed surface, and on this surface some fluid is flowing. If we will consider on this surface some fluid is flowing, suppose this is a fluid which is flowing over this surface. This fluid is flowing over this surface. This is the fluid which is flowing over this surface. This we will discuss about how fluid will vary from your solid. How fluid will vary from solid. Now if this fluid is flowing which has no distinct shape of its own like that of solid, now if we have to analyze the fluid, we will take some sections. I would take the two sections in your fluid part, in this fluid, I will take one this section which is your A, B, and one section I will take this C and D. I will take two sections in this fluid. This is your section A, B, and this is your C and D. Or as we know from your thermodynamics, we will say this A, B, C, D is my control volume. This A, B, C and D is our control volume on which our discussion is concerned, or on which we are concerning our discussion. Now if I apply a shear force, now again we will apply some shear force on this fluid, and we will apply the same shear force. We will apply the same shear force F, which is of 10 kilonewton on this fluid element. On this fluid element, or on this control volume, we will apply a same force F, which is of 10 kilonewton on this fluid particle. Because of this force, the fluid particle will start, or the fluid layer will start moving. Suppose at time t is equal to 1 second, at time t t is equal to 1 second, suppose your AB section will go like that. Suppose AB section, this AD layer of the fluid is fixed. This is known as no slip condition. We will study it later. The fluid layer which is in contact with a solid boundary will be fixed, or we will talk this as a no slip condition. So because of this shear force F, the layer AB will become your AB dash. When we will say this is at 1 second. At 1 second, after the application of force, in 1 second the fluid layer will become AB dash, and here the fluid layer will become your C dash D in 1 second. C dash D in 1 second. Now, if we will say we will apply this force continuously for some time, then because of this force F 10 kilonewton, we will say that because of this 10 kilonewton force, if we will say after 5 seconds, this layer AB will become your AB double dash. AB double dash. After say some 5 seconds, and this layer will become your DC double dash. DC double dash after 5 seconds, which means that whenever we apply some shear force on a fluid, however small this shear force may be, the time at which the shear force is acting, the fluid will move continuously. The fluid will flow continuously, means we will apply this shear force F for 5 seconds, then for that 5 seconds, the fluid will move continuously, means the shear strain or the deformation of fluid layer, will change continuously with time. The deformation of fluid layer will change continuously with time, means when the force is acting in 1 second, this is our deformation. This is the deformation of fluid particle or fluid layer in 1 second. When time will become your 5 seconds, then the deformation will be this one. This will be the deformation of fluid layer in 5 seconds. It means that in fluid, whenever we apply a shear force, the time at which the shear force is acting on a fluid particle, the fluid particle will change its position, will flow continuously until the force will act. Until the force, please note each and everything, until the force will act, the fluid will change, the fluid will flow continuously, and if the fluid will move continuously, the deformation or the shear angle or the shear strain will change with respect to time. And if the shear strain will change with respect to time, hence in case of fluid, the shear angle, the shear strain is changing. Hence in case of fluid, we are more concerned about the rate of shear strain. In fluid mechanics or in fluid particles or in fluids, your air or liquid, we are more concerned about rate of shear strain rather than the shear strain. In solids, this shear strain, which we will known as gamma, is constant for a constant force. Hence in solids we are concerned about your shear strain. But in case of your fluid, we are more concerned about the rate of shear strain, because in fluid the shear strain will change continuously with time whenever we will apply some shear force. And also we will say that in solids, if this shear force is in the elastic limit, then if we will remove the force F, the solid will regain its original shape. But in case of your fluid, if this force will be removed, in case of your shear force, in case of your fluid, if this shear force will be removed, then the liquid or the fluid will not regain its original shape. The fluid will not regain its original shape means, if I will remove this 10 kilonewton force, after 5 seconds, then after 5 seconds if I remove this 10 kilonewton force, the liquid will stop at AB double dash and DC double dash. It will not regain its original shape. It will not come back to AB and CD. It will be stopped here only, AB double dash and DC double dash. So in case of fluid, after the removal of shear force, the fluid will not regain its original shape, and the time at which this shear force is acting, the fluid will move continuously, and hence the shear strain will change continuously with time. Only because of this, we are more concerned about the rate of shear strain in your fluid rather than the shear strain. But in case of solid, for a constant force of 10 kilonewton, the shear strain gamma will be constant, say 1 degree. So if we will apply this force F for say 1 hour, this gamma will not change. If we will apply this shear force F for 1 hour in case of solid, this gamma will not change, and hence we are concerned about shear strain in solid. But if we will apply this shear force of 10 kilonewton for 1 hour in the fluid, the shear strain will change continuously. And the fluid will flow continuously, and hence in case of your fluid, we are more concerned about the rate of shear strain, means at what rate your shear strain is changing with time when the force is acting, and after the removal of force, the fluid will not regain its original shape. So this is the difference between your solid and your fluid. This is the basic difference between your solid and your fluid. And if we are summarizing this, we are say what are the basic difference between your solids and your fluids. What is the basic difference between your solids and fluids? If we will talk in terms of your fluid mechanics, we will not talk in terms of your forces of attraction, shape and all. We will talk now with respect to our fluid mechanics chapter or subject. We will say, in case of solid, by applying shear force, I would write, by applying a constant shear force in solids, by applying constant shear force. Please note, we are applying a constant shear force, and if we are applying a constant shear force in a solid, then the solid will deform. And this deformation or this shear deformation. We will say this shear deformation will be constant for a constant shear force. This shear deformation will be constant for a constant shear force, and if this shear force or the shear strain will be constant, we will say in case of solids we are more concerned or we are interested in finding more concerned about the strain. We are concerned about the strain, or you can say your shear strain or your shear strain. And also we will not know that in case of solids, if the forces are, if your shear force is in elastic limit. We will know what is the meaning of elastic limit. From our strength of material, we will know that what is the meaning of elastic limit. Elastic limit is that limit of a material in which if we apply a force, but then after the removal of force, if that force is in elastic limit, the solid body will regain its original shape. There will be no permanent deformation in that body if the force is in elastic limit. So if the shear force is in elastic limit, we will say that the solid will regain its original shape. Solid will regain its original shape. Solid will regain its original shape. So this is the concept of your solid, how we can define a solid body. Now we will say what are the difference between a solid and fluid. So in case of fluid, if we will say by applying, in case of fluids, if I would say by applying a constant shear force, in this also we will apply a constant shear force, the liquid will start flowing, or we can say that the liquid will deformed continuously. This is the most important word. In case of your fluid, the liquid will deform continuously when shear force is acting. Till you can say till shear force is acting. We will say whenever your shear force is acting, the fluid will be deformed continuously. Fluid will be deformed continuously to the time at which the shear force is acting, and from this we will say that because of this, the deformation or the shear deformation in case of liquids, the shear deformation will change continuously with time. The shear deformation will change continuously with time. And if this shear deformation will change continuously with time, we will say that if this is so, then we are more concerned in fluids to the rate of shear strain. We are more concerned in case of fluid to the rate of shear strain rather than your strain, because the shear strain is changing continuously, so we are interested in finding the rate of shear strain, means at what rate the shear strain is changing with time. So we are more interested in finding the rate of shear strain. And in case of your fluid, if shear force is removed, we will say if this shear force is removed, the liquid will not regain its, this is the most important thing, the liquid will not regain its original shape. The liquid will not regain its original shape because of when we are removing the shear force, it will not regain its original shape. Hence, we will say that a fluid is a substance which is here you can say not liquid, this is a fluid. We will say here liquid or fluid. You may write here or fluid, which include both gases and liquids. So we will say a fluid is a substance which is capable of flowing under the action of a shear force, however the small shear force may be. What is the meaning of this? If you are applying a very less shear force on a fluid, then also the liquid will move. If the liquid will resist a shear force, if any fluid or if any substance will resist a shear force, that means if you are applying a shear force on a substance and it will not deform, if you are applying some shear force on a substance, it will not deform, then you cannot say that substance to be a fluid. A fluid is that substance. You are calling a substance as a fluid only and only when it will not resist any shear force. If a very small shear force is acting on a fluid, it must have to be flow, that the deformation must be there, then only we can say that that substance is a fluid. If any substance which is capable of resisting a shear force or capable of not undergoing any deformation because of shear force, that substance is a solid, not a liquid or not a fluid. A fluid must have to flow when a shear force is acting on it. So this is the difference between your fluid and solid. So from here I will conclude that if shear force is not there, in a fluid, then fluid will not move. Means for a fluid to be flowing, then shear force must be there. It means if a fluid is at rest, then there will be no shear force in that fluid. This is the very important concept you have to remember. You please note it in your note form, that you can note it in your note form. This is a very important concept we are studying, that if a fluid is at rest, If a fluid is at rest, means it is not flowing, then there is no shear force. There is no shear force. There is no shear force acting on that fluid. There is no shear force acting on that fluid. Means when we are studying fluid statics, when we will study fluid statics in which your fluid is at rest, in which our fluid is at rest, then there shall be no shear force acting on that fluid. Because we will know that if a very small shear force is acting on a fluid, it must flow. Then if a fluid is at rest, then there shall be no shear force acting. We are saying no shear force. I am not saying no forces. I am saying there shall be no shear force acting on that fluid. Means there may be condition will be there. There are some other forces acting on that fluid. But if a fluid is at rest, there shall be no shear force. Means in case of your fluid static, when your fluid is at rest, there is only normal force acting on that fluid. Only normal force is present. Only normal force is present. Hence, we will study when in pressure measurement or in Pascal law, we will study that when a fluid is at rest, the normal force is acting on that fluid, which is known as your pressure force or a compressible force. So if a fluid is at rest, there shall be no shear force, only normal force is present. So this is the difference between your fluids and solids. So we will study the fluid properties in our next lecture. Thank you.